Warning: this video depicts a brand new Losi Nascar motor being ruined during break-in. Viewer discretion is advised.
Hello racers, and welcome to today's video. In today's video, this is episode 2 of the Losi Mini NASCAR series. And in this video, we're just starting to free up the drivetrain in this car. And first step is we're going to break in the motor. Now, there's all kinds of different ways of doing motor break-in. I'm going to try the water method of motor break-in. So let's get into this video. Okay, and we are back. I just took the new motor out of the car. You can see it here with the wires on it, straight from the car. And I also have a motor that I just went through a break-in process. Now I used a different process on this one, and we're going to compare the two. But first, let's just talk about what the heck a motor break-in is. Like, what are they actually doing? You hear people talking about that all the time. And what they're doing is they're running in the motor, and they're mating the brushes that are inside the motor to the surface of the commutator in the motor. And the commutator is connected to all the little coils that are inside to make the magnet. The goal of that is to get those surfaces mated as close as possible to move the most power from the battery into the coil to make the strongest magnet that you can make. Because the strongest magnet will give you the most power and the most RPM. So that's what they're trying to do. But these motors are a little bit different, and I'll kind of show you a picture of how they are different. So, I made this very primitive diagram. So in the motor, this is looking at the motor from the end. And you can see that I kind of drew this. Now inside is the commutator, and it's spinning around, and that's the new brush. And I drew it like this shape where the brush is square and flat, and it's not arced or wore in around the commutator. And even worse, here is the like a rudimentary picture here of the side of the motor, like this. And you can see that the brush is actually shaped like an arc, where it only touches the two outside edges. And it's kind of molded to be raised in the middle. And they do this so these motors last a long time in your car. Probably this motor would actually spin for, who knows, 3-4 seasons. Now it might not spin with full power, but the brushes are designed that they don't touch the commutator very much. So the commutator is the soft part that would wear out. And here's an example of what a brush would look like. Here's the top and bottom there. And it's kind of hollowed out in the middle. So as this wears in, there's like new parts to be worn into. And that's how they designed it. What we're trying to do in this is wear those pieces together. So, how do people break them in? That's another good question. Well, typically if you look online, you'll hear people, racers and things, say they'll either break it in through a water dip, or they'll just run the motor low. And when I say low, they mean at low voltage. Typically you see them say 1 or 3 volt. And where that even comes from is from people using like batteries to break it in. Back in the old days when brushed motors were popular, they would just use some batteries. And so here's a method that I tried. If you use AA's, you'll go through an awful lot of them, but this is an example. Each battery is 1.3 volt, 2 of them is 3 volt. People could get these little holders, and that's where the 3 volt come from. You'll hear people say that they water dip their motor, and we'll do an example of this motor having a little water dip before we break in. But the reason that they've run it in water is because it keeps the motor cool while it's breaking in and provides a little bit of load. Now, if you look online, you'll hear this racer say they do it for 10 minutes, this racer say they do it for 20 minutes, this racer say they do it for 1.5 volt. Some people just say, I don't do anything, I just toss it on the track and away I go. But the best practice, or common practice, all seems to be to run these at low volt. So what I'm going to do is I'm going to use my power supply and use this voltage regulator. And I'm going to break my motor in at 3 volt. And why 3 volt? Well, because it reduces heat, because you don't want these motors to get hot and wore out during the break-in process. It reduces the arcs. If you notice when you first break these in, you'll look inside and you'll see almost like little sparking. Well, those little arcs are the hopes and dreams of speed leaving the motor. What's happening is those little arcs are like welding inside this motor, and what they're doing is making small little pits into that commutator, so you don't want to have any arcing. And low volt is also reducing, if these two pieces aren't completely mated together, there could be some bouncing and vibration happening, so you want to keep that as low as possible. And then the final question is, how do you know when your break-in is done? You hear people say, oh, I run it for 10 minutes and that's good. Well, how do you know it's good? So what we're going to do is test a motor that I know is broken in. This one here has been run on the system here for 7 hours. No load, just out in the open. I had it running on the, just running hooked up. And when these are done, and let's just put it on, and you can see, when they're done, they will be approximately 1 amp draw and spin a little over 10,000 RPM. So let's give that a little test. I'll get my little RPM tester here so you can actually see that happen. Got one of these for RPM testing. All right, so let's do it. So let's just turn it on. We're set to 3 volt. And I'll just zoom in so you can see. So you can see here, this is running at about 3 volt, 2.9, and the amp is about 1 amp. In a well broken in motor, you can see the amps in green fluctuating. You'll notice that the fluctuations are very low. Okay, so that is a broken in motor. Oh, and let's just double check the RPM. We didn't do that here, so let's just turn it back on. I just use it'll flash off the, I don't know if you can see that number here, I'll bring it up. 10,349. So 10,300 at 3 volt. Perfect. Now let's just try a fresh out of the car, never been run motor. Let's turn this off. And let's just see what we get. And you can see 3 volt, 0.7 amp. So when these first start out their little lives, they'll be around 0.6, 0.7 amp. And as those brushes wear into the commutator, this amp draw will increase. And why does the amp draw increase? Well, it's more power going through the commutator into those coils. You want to see this amp as high as it can get, which is only about 1 amp. But the more it breaks in, the higher that amp will go, and not lower. Okay, so let's get the water dip method put together, and we'll get back to the video. Okay, racers, I just thought before I get into breaking in the motor, I thought I'd show you exactly what is going on inside the motor, and how I explained about the commutator and the brushes and the shape and all that. I have a little microscope I can just put on there. And what I'm doing is I'm just going to look through the hole in the side of the motor, and we can look down and we can see the commutator and the brushes. This will just help us see it a little better. Okay, so let's see if I can get one to show. Okay, so if you can zoom in or press pause on your video, you can see on the right side of the camera the shape. Looks like a little horseshoe, and it's touching top and bottom of the commutator. You see the copper silver commutator there, and that's the shape. And if you look really close, and I'm just trying to move it around, you'll notice that the commutator is nice, shiny copper. So it's been barely used, but it's kind of worn in just the places where you see those points touching the commutator. And that's what they're doing in a motor break-in, is they're trying to just run those brushes in so more of the brush is touching that commutator. You can almost see light through the brush into the other side. As I was looking at this one, you can see that little faint glow. I don't know if it shows on the camera, but I just wanted to show you that. We can take a look, and that's how I know exactly what is in. And then after we do our motor break-in, we'll take a look and see what this looks like when it's done, like how wore out it is or how well the brushes have gone in. So there we go. So let's get this prepped, put it in our water. We'll do our break-in. See you in a sec. Okay, here we are. We're back and we're ready for our polar dip. So what we're going to do is put this into the water dip method. Now, in my little mason jar, I have distilled water. And the reason I have distilled is because there's no salts or minerals or anything like that. Because remember, one of the things we want to do is prevent arcing inside the motor. And if there's any kind of contaminants in the water, they'll be spinning in around there and also cause arcing in the motor while the brushes are breaking in. So we don't want any of that. So I went and I got some distilled water. So again, we're going to use the power supply versus batteries, just so we can kind of monitor that amp draw. I'm going to try a 5-minute water dip. And then we'll test it after 5 minutes. And then we'll try it for 10 minutes. And what our goal is we want to have this drawing 1 amp, freeloaded, and over 10,000 RPM. And that reminds me, we didn't do the RPM check on this when we had it. We did look at the amp draw, which was about 0.6. So there we are, spinning. We can see 0.7, 0.069. So we see that it's floating in around low 7s, high 6s. Let's just double check the RPM. And we see RPM is about 10,060. So it's very low, 10,000 RPM. So what we do for a water dip is I'm going to put it in totally submerged. I'm going to kind of wish I had brought one of my, see if I can hang it from a little, like something like that. I know it ain't the best, but this is what we got to work with. Let's do it. Okay, so here we are, submerged, 3 volt, floating around in there, and you can see it's pulling almost 6 amps and really churning up the water because there's a built-in fan. There's a built-in fan in these. Here we go. This is quite an ordeal. Let's just keep an eye on the clock. It's 12:12 at the moment. Kind of thinking maybe my cup's a little bit too small. My cup runneth over. So what I'll do is I'll let this break in 5 minutes, and then we'll take a look and see how this turned out. We'll see you in a second. Okay, racers. So we're about at the 5-minute mark. One thing you can notice is that it's up to about 6 amp, which is the capacity of this little power supply. So it kind of drew an extra amp during this process. And we're only at 5 minutes in. So let's turn this off. And I'll take it out of the water. I found one of the tricks maybe is to have a bigger glass. And we'll swap that out. So now I'm just going to dry this off, and then we'll do our measurements. See you in a sec. So here we are, back. Dried the motor off pretty good. I did notice the water got pretty cloudy. So probably all the little particles of the copper, brushes and things are all coming off. Now before we do a little test here, let's take a look at it under the scope. Let's see here, so you can see. Let's see if it made any appreciable change in there. Let's take a look. I do see some water still around, not 100% dry. The brushes still have that arc to them, like we saw before. You can see there, and pretty much in the center of the camera. I don't notice any additional scratching. I would have expected to see some wear if it was touching in the middle. So let's let it, just put this aside. Let's give it a little test and see. Let it spin out that water and see if we gained any extra current. Remember, it was about 0.6 or 0.7 at 3 volt. Let's let that spin around a bit. Okay, so I don't know if you can see this on your... Let's get these wires apart. Now, I see that it's 0.7, close to 0.8. So I might have picked up a 1/10 of an amp in that 5-minute break-in. And let's just test the RPM and see what we get that way. And it looks like the RPM has increased to 10.18. Before it was 10.16. So from here, let's do another 5 minutes of break-in. I'm going to get a bigger glass of water. I noticed that it just made a huge mess. So anybody doing these break-ins, this is my first time I've done a water break-in. It just makes a mess. So be ready for that. Okay, let me get set up for the next test. And here we are, 4 minutes in to the second 5-minute break-in. Just wanted to show you as this is going, it's still about 5.9 amps that it's drawing. And that's one thing that I'm a little bit suspicious about with this water break-in method, is that it does cause the motor to draw a lot more current. And I can see that with my little power supply, it's a constant voltage power supply with a maximum current draw, and the maximum draw on this is set to 6 amp. So right now it is, you can see that it's dropping the voltage to 2.8. So it's trying to maintain that overall 6 amp draw. So in the intro we were talking about trying to keep the current low to prevent the arcing and all that kind of stuff, and the water method does seem to raise that. You might break it in a little quicker. So we're going to keep all this in mind as we complete our tests. So I think we are done our second 5-minute break-in. Let me just go get, turn this off and clean the motor up, and then we'll do our second test to see if it's been improved. Okay, we are back from the second 5-minute break-in. So it's been a total of 10 minutes of break-in, and I just wanted to take a look at what's going on in the motor. Taking a look at the brushes, and we can see in the center of the screen a brush. But what I'd notice here, and I'll point it out if you can see it on the screen, you see this little mark right here? It does not look like a nice shiny piece of copper. It looks like there's a gouge or something, and it looks like it's both top and bottom of that brush. Just spin the motor slightly, and we can see the same thing on the next slot in the commutator. So that tells me that this wear that's happening is really accelerated in the water break-in method. And I think I'm done with water breaking. Maybe you guys know a better approach, but from what I can see with the microscope, it is actually wearing the commutator quicker than it is the brushes. And it might be that 6 amp load. And that was only done in 10 minutes. I did the 5 amp and the, or 2 5-minute tests. Let's just run it on the power supply. Let's not be too hasty. Once again, 3 volt. And I don't know if you can hear it, but the motor does sound noisy. So it's like the brushes are kind of bouncing. You see that it is at 0.7 volt. It's very stable, or 0.7 amp, very stable. So I'll give it that. We'll give it that. Let's take a look at the RPM. Maybe it has more RPM. And it's telling me 10.0084. So with the second break-in, we did not get any more. Whoops, misreading there. Slightly more as it's going. 10.119. So in the second break-in, we did not get any more amp draw. And in the scope, we saw more wear. So I'm not really sold on the water break-in approach. Because with the, let me just try that again. Let's just compare that to the approach that I just let it wear in naturally on the bench with a fan blowing on it. Right? We saw this quite a bit quieter, and you can see the amp draw is much higher. So if you were going to pick between the two motors, the bench break-in method is by far the more superior from what I can tell. Okay, so what I'll do is I'll see what I can do with our test motor, see if there is some more power in there, and we'll just do a little video wrap up here in just a moment. Hey racers, and we're back. As you can see, we're back in the home workshop. Just wanted to give you the final summary of the water break-in technique and trying to recover this motor from what looks like a botched break-in. So as you saw in the previous section, tried the water dip technique, ran this at 3 volt in the water, distilled water, and we found that the commutator was gouged by the brushes during that process. And what I've done is I've used my little power supply here, and I've tried to break in just using the wear-in method. Put it on for half hour at a time, checking the brushes, cleaning, all that type of stuff, to see if I could repair or wear in the brushes to smooth out the commutator. Let's just see what we found. Well, we're going to try to use the camera again. I'll zoom in, make sure we can see. Okay, so let's see the results of the extra. I ended up doing 4 more hours of break-in. Okay, so we can see on the screen the brushes, and I'll just kind of turn. You can see that little notch right in the middle of the screen here. Little notch that was taken out. Not sure how clear it is on camera, but you get the idea. You can see that the brushes are still not 100% seated, and I don't think they will ever be, and we'll take a look at the picture there in a minute. But you can see right there where the brush is turning and the commutator, there's a notch out of that happened during water break-in. You can see on this side once again, and this side once again. So you can see that the commutator itself, I'll just pan out, looks like it is wore in across the face of it. So the brushes are wore in. You can see that they're carbon, probably lubrication, and probably some damage I also wanted you to see that there's a lot of end play in this motor, and as I move it around, you can see that the commutator kind of scrapes across the brushes. Probably not helpful. So, end result. I'll just zoom the camera back out here. End result of this little motor. What I found for the yellow motor, in the end, it drew about 7 amps of current on the power supply, and it spins about 10,560. So, end result, it is actually less powerful after the break-in than it was before, oddly enough. So the poor little guy, he basically has donated his life to science for figuring things out, but he did not improve with the break-in. And just to compare against that red motor that we looked at earlier, we'll just take the top number here. So at a 10 amp load on the motor spins at 23,000 RPM. That was the red one. The top amp, 10 amp on this motor, spins 21,000. So it's at a 2,000 RPM disadvantage after break-in. So it didn't really help. But what we did is and just to take a look at that brush, remember we saw the little notch out of the side? This is the way it's shaped, like a little I-beam. So at this point we saw that the commutator was wore across the face. So that means that the end plus the center plus the other end was broken in to touch that whole face. So even though that we did see a little edge, that didn't really bother things. Okay, so that's the way that worked. But we did get some lessons learned. So let's just review our lessons learned. One is that if you're going to do a water dip method, use very low voltage. I used 3 volt, but in hindsight, I should have used about 1.5 volt. And the reason for that is that the water break-in method does draw a very high current, and the current can damage the commutator like we saw. So that's one lesson that we learned. The other lesson is that we should check these motors at short intervals. Like I checked it every 5 minutes, but maybe I should have checked it every 2 minutes or so, up to a 20-minute break-in at the very most. I did a 10-minute break-in, and that was enough to send this poor little motor to into the parts bin. Next thing we learned, you should use the distilled water because it has the least contaminants that we could put in there. No salts, no minerals. And the next thing we learned is you should use a large bucket of water. I used that little container, and it was sloshing around in there, and it was probably the sloshing that ruined the motor, because there's a little fan built in. There's a little fan built into these motors, and probably that was agitating the water and sloshing around, and that probably like moved the brushes and they vibrated against the commutator. So that's a danger that you have to consider. Keep it low voltage, keep a large bucket of water that it's going in. Now the whole goal of a break-in is for this little motor to draw 1 amp on free spin, and currently this little guy draws 0.7 amp on free spin, which probably, as you could see, it was getting a little bit wore out. So I don't think more break-in is going to help this little guy. It's not was less than ideal, that's for sure. So I'm going to do another video just doing the wear-in method just to compare, and you can see that happen. And we'll follow the same format as this, where we kind of look at the scope, look at the amp draws, see as many details as we could. So if you guys could let me know in the comments, is this level of detail worthwhile? Just let me know. So next video, wear-in method. Like if you like this type of thing, comment if there's enough detail in there, and subscribe to get caught up on all these videos that we're doing. Thanks. We'll see you in the next video.